Okay, so we've got the basic groundwork down for how to do Punnett Square problems. Let's do a bunch and see if we can get confident at this. I've got the steps, our Punnett Square drill down here in the bottom right corner because I was worried about running out of space up here. So we'll follow along with that as faithfully as we can. And the first thing we notice is they've got a new trait for us here. We've been talking about human eye color, and then we talked about pea plants with round or wrinkled peas, and now we're talking about dog fur. And they tell us right off the bat that black fur color is dominant over yellow. So that's enough for us to get our legend started. Black starts with B, and black is the dominant color, so we're going to say big B is the allele for black fur, and the lowercase version of that, lowercase b, is the recessive allele, which in this case is yellow. So normally you take a letter that makes sense for the dominant allele, B is for black, and then the lowercase version of that is for your recessive allele, whether it makes sense or not. So that takes care of those, and that means the kinds of dogs that you can have are homozygous dominant, that'll be a black dog. You can have heterozygous, which, what color is that? It's black again because black is dominant. So if you have black and yellow, the black just runs over the yellow. And if you have little b, then in that case only you get a yellow dog. So there's our legend. Good. Step one complete. Now, parents' genotypes. Oh, okay, they aren't even getting into Punnett Square yet. You can only do a Punnett Square if they tell you this parent has a kid with this parent, and that's not what's going on here. They're just saying, explain how a homozygous black dog, that would be this one, big B, can have a different genotype than a heterozygous black dog. Well, our legend pretty much answers this question. If they wanted to make this a little harder, they'd say, like, explain how two black dogs could have different genotypes. And the answer is, you can be homozygous for black, or you can be heterozygous for black. You can be big B, or big B, little b. As long as you have one or more dominant alleles, as a dog, you'll have black fur. So either one of these would be a black dog. You can't tell them apart just looking at them, but genetically they are different. This one will have nothing but black puppies. This one, depending what the other parent is, might have yellow puppies because it's capable of passing on the yellow allele or the black one. So that's the idea with that, is that, as the legend shows very well, there's two different genotypes that will both produce a black dog. Could the heterozygous black dog have the same genotype as a yellow-haired dog? Short answer, no. If you're a black dog, you're one of these two genotypes. If you're a yellow dog, then you're little b. So no, there is no way to be genetically the same and have a different fur color. Can't happen. The legend says these are the two ways you can be black, this is the one way you can be yellow, and there is no overlap between those. So I apologize. This turned out to not be a Punnett Square question, and I needn't have bothered putting this thing up, but it's talking about the concepts that we're using, and so that's good stuff. Let's grab something else and see if we can get some Punnett Square action going. Here we are. So now we're back to pea plants and round and wrinkled plants. So we've talked about how those alleles look, although I will put them up again. And here are our steps. I'll put that as far in the corner as I can get without losing them. Okay, let's see what we can do here. A pea plant with round seeds is cross-pollinated with a pea plant with wrinkled seeds. Okay, as soon as you know they're talking about pea plants, that tells you what you need to get the legend started. This would either be explained in the problem, or we're going to have to use traits that you've seen before so that you know what to put in your legend, and this is a familiar one, so I will just remind you that this means big R stands for a plant that produces round peas, and little r stands for a plant that produces wrinkled peas, and that means the plants we can get are any of these three. The ones that have a big R will produce round peas because dominant wins. And if all you have is the wrinkled allele, then you will produce wrinkled peas. Okay, legend done. Oh, and they remind you about it here too, so that was nice. And they say a pea plant with round seeds is cross-pollinated, which there's a lot of special terminology about plant reproduction, but this just means a pea plant with round seeds is crossed with a pea plant with wrinkled seeds. Now, we're going to run into a bit of trouble when we try to do parent genotypes here because a round-seeded plant could be either one of these guys. What I normally do for that is I put big R blank. This plant is either big R or big R little r. I'm not sure which, so for now all I know for sure is the first letter is a big R. The second one will fill in soon, hopefully. And they say it's crossed with a pea plant with wrinkled seeds. That one's easy. If you have wrinkled seeds, you have to be little r. It's the only way that can happen. So that's what we know about the parents' genotypes so far. And then in 2a they say, find the genotypes of both parent plants if the round-seeded plant is heterozygous. Ah, okay. So this isn't such a mystery. They told us it's hetero, meaning one of each. There we go. Mystery solved. If they hadn't said that, there would have been trouble. I would have had to probably try 2 combinations and see which one worked out, but now we know the genotypes of both parents. And now that we have the parents, they say, what are the genotypes and phenotypes of the F1 generation? So if we cross these plants, what are we going to get? We have steps for that. We got the parents' genotypes. The next thing we'd have to do is set up a Punnett square and put in the parents' gametes. So here's a Punnett square. There's something wrong with the square I just wrote. Do you see what it's going to be? It'll be clear in a minute, but if you saw it coming already, well done. For now, I'm just going to keep walking right into the trap, and we'll get there in a minute. This parent can produce one of 2 gametes, either big R or little r. So here's the big R, here's the little r. This parent, well, this parent's pretty predictable. They always contribute a little r. All their kids get a little r from them, which means I can put little r here, and it's kind of pointless to put it again. So I'm just going to flip my pen over to white here, and this isn't going to be a Punnett square, it's going to be a Punnett rectangle again. There's no need to have 2 columns that both have little r in them. They're going to be exact copies of each other, and we don't need to do that. So this will be enough. This parent can produce one of 2 gametes. This parent always produces the same one, so we don't have as many possibilities as usual here. So what do we get for our F1 generation? This is big R, little r. And this is little r, little r. Big R, little r is round. And little r is wrinkled. I have trouble writing that in this space, so I'm just going to put W, R, N, K, and hope you'll agree with me that that spells wrinkled. So there's our genotypes and phenotypes for the F1 generation, and if we had to write ratios for them, you could either say it's 1 round to 1 wrinkled, or you could go percentage and say it's 50% round to 50% wrinkled. And for the genotypes, you could say it's 1 big R, little r, to 1 little r, or you could write 1 heterozygous to 1 homozygous recessive, or again you could go percentages and say it's 50% big R, little r to 50% little r. There's a lot of little variations in how you express this, but there's a lot of acceptable ways to do this is the point, so don't stress too much about how you write this. Your teacher might have a favorite way and encourage you to use it, and that's fine, but there are a lot of ways that people will understand this correctly as long as you get the numbers right. So these plants up here were our parental generation. This group here is, I'm going to label the F1 generation, and I wouldn't be too surprised if the next question is about the F2 generation. And hey, look at that. Genotype and phenotype of the F2 generation if two heterozygous round plants, meaning these guys, the hetero ones, were allowed to cross-pollinate. So for our last step now, we're taking a big R little r and we're crossing it with another big R little r. So we're back to the beginning of this. Legend, already covered. Parents' genotypes, we got them. These are the new parents from the F1 generation. So these were the grandparents, these are the parents, and now we're going to have their kids that we'll work out in a moment. Punnett Square and Gametes. In we go again. Here's our Punnett Square. Does it need to be a 2x2? Yeah, it does, because there's two possible contributions from each of these parents. This is the most complex Punnett Square we can do so far. So mother pea plant can contribute big R or little r to her kids. Dad pea plant, exactly the same. And that means the kid pea plants can be big R, big R. This one is big R, little r. This one is little r, big R, but remember to switch the order. And this one is two littles. And for phenotype, we get round, round, round one more time, and even with this pointier pen, I'm still going to use the short version of wrinkled. Okay, so there's the offspring, and if we count them up, we get 3 round, oops, wrong place for the colon, 3 round, colon, 1 wrinkled. Or if you do percentages, it would be 75% round to 25% wrinkled. And for genotypes, we get 1 big R, big R. There's 2 ways you can get big R, little r. This one is more common because there's 2 ways it can happen. Either you can get the dominant from dad and the recessive from mom, or dominant from mom, recessive from dad. The fact that that order doesn't matter means it's twice as easy to get this one. And the last possibility is you get double recessive little r from both parents. So there are the 2 ratios. That's all they wanted.